about the 8051 emergency programming. So in that we have seen about yesterday class. So in the yesterday class we have seen very important basics. So something like as here first what we have started is we have started with the I will start with the programs, whatever the programs we have discussed so far. So I will try to share that. Yes, see here. So first what we have started is, so we have started about sending the values to the port P0. Important point here you need to know is, so how we can able to send a data to a port P0. So there's the thing here we are going to be having a very important thing, P0 num of Z. So there we can able to send the data continuously into the port P0. So directly we can able to see. Next, after that, we have seen about the continuously toggling of the P1, port 1. So if I have connected any LED to the port 1, so I need to toggle the LED. So how I can able to do continuously is, I have changed the for loop and I have taken the data as a P10 x55 and P1 is equal to 0A. So with this, we can able to toggle the LEDs which are going to be connected to the P1. Okay. Next, after that, we have seen about how to send a -4 to +4 data. So we have seen about the two things, signed and unsigned. So there we are going to be having a signed data. The signed data is going to be in between the -4 to +4. I need to send. So that's why. So I take as a char, CAHAR. So this is going to be given as the signed one. So whereas for loop we require the unsigned. So that's the difference we are going to be having. So in the signed we are having a -127 to 120, -128 to 127, whereas the unsigned we are having a 0 to 255. So that's the differences we are going to be having a signed and unsigned characters. So after that, what we have seen is, so we have seen one more thing, the simple program. So there we are going to be toggling the bit D naught or P1.1. So directly, so here in this program, we have taken the one more important thing, so a keyword which is going to be called as the S bit. So S bit is going to be representing, so one bit data. So this one bit data is nothing but the port, whatever the port we are going to be, we need to send the data. So that port is going to be represented like this, P1.0, and you can able to understand this one. Okay, so like that. Next, so after that one, we have seen that. So we need to toggle the P2.4. So for that one, so we are going to be giving like this. S bit. So first I will give the one. Afterwards I will give the 0 like that. So this is the thing. And after that, you have seen about taking the data from one port and sending the data to other port. So this is the thing. So taking the data, in order to take the data, the port must be act as a input port. So here I will make that one as a input port. Whenever I make this one as a is equal to 1, so then that became as a input port. Next, so from input port, I am going to reading. So these are reading data. So next, whatever the data we are going to be having, that is going to be sent to the AA. Where, so if it is a 1 or if it is a 0, like that. So next, so we have seen about that one. So we have seen the trials of this. Next step. After this, so today we will start some more programming. Okay, so something like this. So I will try to yeah now. Yes. Hello, are you able to see my screen?
Yes, sir.
Okay, okay. Please, one more time, please confirm that. Now,
No, sir.
start. Okay. Yeah. So we will start the 8051 programming. So today, what we will see is we will try to calculate the time delays like this. So there are two options to have a delay. So one is by using the 8051 timer and timer. So timer and counter registers. So I will use this timer and counter registers. So by using this timer and counter registers, I can able to create a delay. Or I can able to a simple for loop. So there I can able to generate the time delays. Okay. Yes. See here. So delays can be observed either on the oscilloscope or using a simulator. So we cannot able to observe because the frequency which are going to be working the 8051 is a 12 megahertz. So if I try to see one pulse also, so we cannot able to see the change. Okay, so that's why we required oscilloscope or simulator to find out the delays. Okay, so in creating the time delays for the loop factor, we need to be considered. So how much time the loop is going to be rotating. So that will give us the time delay. Okay, so we will see that one. So to calculate the time delays, if I go for the assembly level language programming, ALP, so which is called as the ALP. So then how we can able to calculate the delay. Okay, so first let us take, I am having a program. So the program consisting of 10 instructions. Let us find out it is going to be having a 10 instructions. For example, let us take 10 instructions it's going to be having. So in the 10 instructions, so some of the instructions are the 3-byte instructions, some of the instructions are the 4-byte instructions. So then I will calculate the total number of bytes which is going to be having in that one. So I will try to find out how many mission cycles are needed, how many mission cycles are needed to execute each and every instruction. Let us take for one instruction, it's going to be having a three clock cycles, or for other instructions, it's going to be having 4 clock cycles. So for our purpose, what I am going to taking is, so the total entire program is going to be having 3 clock cycles. Okay, so that is nothing but one instruction will be executed in the 3 clock cycles. 10 instructions will be executed in the 30 clock cycles. So 30 clock cycles is nothing but, so the frequency of operation is a 12 megahertz. So the time period is going to be given as a 1 by 12 into 10 power 6. So then it's going to be having a 1 by is going to be having a 1 by 12 value. So that 1 by 12 value is going to be given as 0 0.083 into 10 power minus 6, or you can able to say as 0.0, that much of the for one clock cycle it's going to be having this microsecond times we are going to be having. So that for 30 clock cycles, 30 cycles we can able to say the multiply with the 30 and it's going to be giving the day. That much of the delay this program is going to be giving. Like that, we can that much of the time it requires to execute the program. Like that, we will calculate the how much execution time it requires. We can able to calculate. Next, here we are using the crystal frequency, which is going to be connected to the XTAL1 and XTAL2. So 805 is going to be having a 2 pins, XTAL1 and XTAL2. So for that XTAL1 and XTAL2, we are going to be connecting the crystal. So this crystal clock cycle will give the clock periods. So those are going to be called as a measure cycles. So measure cycle is nothing but to complete one execution of one instruction is going to be called as a measure cycle. Okay, so compiler will select So accuracy to time delays mainly due to the compiler use. Whatever the compiler we are going to be utilizing, so that will be. So actually in a programming, so whatever I have told just programming is going to be having 10 instructions are going to be having. Will execute in the 3 mission cycles, then the total time period we can able to calculate like that. Whereas in case of the C program, the compiler C will be converted each and every statement into assembly level language instruction, then it is going to be calculated. That's why compiler will produce a different delay. Okay. Whereas assembly level program is going to be having somewhat exact time delays. Okay. So for example, let us take, I am having a simple program. So this is a simple program. The purpose of the simple program is we need to toggle bits of the P1 continuously with some delay. Let us take some delay, whatever delay we require, so we can able to. So here the delay size is unknown. Okay, so let us take, so here for so because we cannot able to calculate all these things, so the compiler will convert this one into the assembly level program, then it is going to be calculated. Okay, like that. But we cannot able to, by seeing this program, we cannot able to calculate the total delay. So but we can able to understand here if we are having some delay, for example by using the for loop. Let us take this is the infinity for loop. Okay, after that one we are having a P1 0x 55. So in the yesterday class we have seen about this one 0155 is nothing but we are having a 01010101 like that. Okay, so starting with the P1.0 it will be switched on like that. So the next one is going to be off, on, off. Next LEDs are going to be offing on like that. So this will then for a period of x is equal to 0, x is less than 2000, x plus plus.
Hello, sir.
Up to that period, yes.
Sorry for disturbance, sir. Your slide is not changing, sir.
Yeah, I will try to share once again. So I have not changed the slide. So I have given only one slide. Write an 8051C program to toggle bits of P1 continuously with some delay. Is it visible?
Yeah, visible, sir.
Yeah. Yeah. Up to that time, so it's going to be giving like this. So the for loop here, the use of the for loop is to produce time delay. Okay. So that's the important thing. Next step. Can you check now? Is my slide is changing? Hello?
Yeah, now changing, sir.
Okay. Yeah. Now check this program. So we need to write a program to toggle the bits of the P1 ports continuously with a delay of 250 milliseconds. Please check this program. So try to understand. So I will give you 1 minute time. Try to understand this one. Then I will tell you. Then you can able to easily understand. Okay. Yes. Listen please. Here I am using a function. Okay. So main is a function. Like that I am using a user defined function. The user defined function is void delay 1. So it's taking a parameters as unsigned int. The parameter name is iTime. These are the parameters. This is the function name. This will give the return value. Void delay 1 unsigned int I time is a function. I am writing this function, user defined function. Okay. Whereas this is the function void main void is a main function. Okay. So this is a user defined function. So this is a system function you can able to say as. Okay. So now the important purpose of here is the problem is what the problem defines is I need to toggle the port P1 continuously with a time delay of 250 milliseconds. Okay, so that's why I'm using here the two variables I and j. So for I is equal to 0, I is less than I time I plus plus. So whatever the values we are going to be giving. So here we are going to be having a 250. So that 250 is going to be taken here and it's going to be generating some delay. That much of the delay is going to be generated like this. Okay. So whenever we call delay 1 250, it goes here and it do for loop. Okay. So for loops, then it produce 250 milliseconds like that. So it's going to be having a program is going to be written like this. Okay, next. Now, so in the previous program, we are having a 250 milliseconds delay. Now, try yourself to write to get a byte of data from P1. Wait half second, and send it to the P2. In the yesterday class, we have seen how to read the P1 and how to send the data to any port. Reading a data from one port and sending a data to another port. Okay. So first, so we try to understand, write the flow chart. So in the flow chart, what we are going to be having is the first step. We need to read the data from the port 1. Read the data from port 1. Next, wait for half second. Give delay. Next, whatever the data we are going to be having, that data is going to be sent to the P2. So whatever the data we are going to be reading from the P1 must be kept in a variable, and that variable data must be given to the P2. Okay, that's how we are going to be having the total program. Okay, read the data, a byte of data from P1, wait half second, and then send it to the P2. That's the overall program we need to try. Okay, the program will be like this. So what I am happening is I need to read total byte of a P1 port. That is nothing but 8 bits. All the 8 bits, that is nothing but P1.0, P1.1 to P1.7. So all these ports bit data this port must be act as a input data. Input. Then only I can able to read the data. Okay, that's why. So the user is going to be giving the data to the P1 port. So that's why it must be became as a make input port. Okay, next. Here you can able to see. So previously we have seen about yes, previously we have seen about the delay. So here also we are using a one function. So this function is going to be called as a void delay unsigned int. This is the user defined function. So that delay, if you give the delay, so there in the delay we are going to be utilizing the for loop. So the for loops will continuously gives a delay of 500 milliseconds like this. First, I am reading the data from the P1 by using the byte data. So this is the unsigned character, my byte. Okay, so I will read the data. So then I will call the delay function. So which will give the 500 milliseconds, that is nothing but a half second. Next, we are having that data is going to be given to the P2. Okay, so here you need to write down the, so I have not included that void delay unsigned int. So that void delay is very similar to like this. So here we have written as a delay 1. Instead that we need to write down as a void delay unsigned int I type. Okay, so next we need to take two variables and we need to give a for loop like this. Okay, so then we are going to be having a 500 milliseconds or half minute delay. Half minute delay is going to be produced by this program. Okay, so try to understand. Okay, read the data from P1, wait for half second, and then send it to the P2. That's how the program will look like. Okay, next. Write an 8051C program. This is another example. Write an 8051C program to get a byte of data from P0. Previously, we have seen as the P1. Now, we need to take the data from P0. If it is less than 100, send it to P1. Otherwise, send it to P2. Okay. Here also, the P0 must be taken as an input. Then only we can able to read the data from the P0 that will be given to a variable, so which is going to be called as a my byte. Okay, so first, so I will try to declare the variable as a my byte, and I will make the P0 as an input port. Okay, so I need to read the data and I need to send the data to the P2 or P1 depending on the condition, such that if the readed data is less than 100, so that's why my byte is less than 100, send it to P1. P1 is equal to my byte. Else, send it to P2. P2 is equal to my byte. Like that. This is a simple program. So which using both P0, P1, using the ports P0, P1 and P2. Not both, is going to be utilizing the three ports P0, P1 and P2. Okay, reading the data from P0 and sending the data depending upon the condition to P1 or P2. So this is a simple program. I hope you understood this. It's a simple one and you can able to easily understood this. Okay. So this is how we can write. Okay. Next. Don't mind. I don't have a activated Microsoft. Word. That's why I cannot able to edit this one. So tomorrow I will do this one. Whatever the things. So here the title is accessing SFR addresses from 80 to FFH. How we can able to access special function registers. The special function registers will lie in the 8051 memory from 802 FFH. So we are having a memory diagram of 8051. So there you can able to find out this SFR. This SFR is nothing but special function registers. So by programmatically, how we are able to access this SFRs? So we need to know that one. Okay. Second. So first, if you take money, going to be having a 002 FFH. So in this one, so from 802 FFH, 802 802 FFH is going to be special function registers. So in the 82 FFH, something like this. So you see here.
Hello, sir.
So
Voice is not clear, sir.
is going to be utilizing. So hello.
So the voice is not clear, sir.
Now
Yes,
is it
sir.
okay? Yeah.
Still
See.
some voice.
I will check one more side. Now is it okay?
Yes, sir.
Yeah. Yes, you can able to see here. So these are the ports. So each and every bit of 802 FFH is going to be utilized like this. You can able to see 80, 81, 82, 83, 84, 85, 86, 87. So these are going to be utilized with the P0 like that. P1, P2, P3. So these are the things which we are going to be utilizing. So we can able to bit addressable. So we can able to select 85 directly. So that what we are going to be pointing is we are pointing at P0 of 5 like that. We can able to address bit addressable these are things. So we will try to write another program by using the SFRs. You can write an 8051 C program to toggle all the bits of the P0 and P2. So we are taking the ports P0 and P2, and we need to have a toggling of this P0 and P2 continuously with 250 milliseconds delay. Okay, use the SFR keyword to declare the port addresses. You can able to see here. So here we are having a port addresses. So for that one, you need to have the port addresses like this. Okay, so see here. So first, yes, see here. Yes, if I am not including the REG51.H for every C program, embedded C program which is written for the 8051 microcontroller will included this one. But there is a condition. If I am not included that one, then the SFR will be used to define the port addresses. I don't in this program. I don't want to include hash include REG51H because I need to use the SFR for the port declaration. So that's why I have taken like this. SFR P0 is equal to 0x80. You can able to see as P0. So 0x80, 090, A0, B0, like this. So I'm telling about the entire thing like this. 80, 90, A0. So P0, P1, P2. Next. So the delay unsigned is nothing but user defined delay program, which is going to give the delay. Okay. Next. Next. Here we are having a while P0 is equal to 0x55. So P2 is equal to 0x55. Next, we will take a delay of 250 milliseconds. Again, we will give the P0 is equal to 0x P2 is equal to 0x So this will be on off. That will be done toggling with the period of 250 milliseconds. Again, we need to give the delay. So like this, it continuously executed. Okay. So like that, indirectly, we can able to address the ports P0, P1, P2, P3 by using this SFR, special function registers. Okay, so that's the thing you need to learn here. How we can able to use the SFR keyboard, which is sorry keyword to declare the port addresses. Okay, so this is how we can able to declare the port addresses, and we can able to read, or we can able to write, or we can able to toggle. Okay, so depending upon that one, we can able to do. Okay, so we can able to modify the program. So to read the data from P0 and send the data to P1 by using this SFR registers. So previously we have seen that one, reading a data from one port and sending the data to another. So by using the SFR keyboard also we can able to do that one. SFR will declare the port addresses. Okay, try yourself that one. Okay, so how we can able to write a program to read a data from P0, port P0, and we need to give a delay, and we need to send the data to P1 by using a keyword SFR. SFR, we need to use the SFR keyword. By using that, how we can able to write. Please try yourself. Okay, if you find any difficulty, please let me know that. Okay, next. So with this, we are going to be moving to the next thing, which is called as a logic operations in the 8051 embedded C. How we can able to utilize the logical operations. So most C languages are going to C language is going to be having the ability to perform the bit manipulations. So bit by bit manipulations can be done in the C program. So like that, here also we can able to do the bit by bit operations. 8051 embedded C also. So like bit operations in the C are AND, OR, XOR, inverter, shift right, shift left. So please look these symbols. Ampersand is nothing but AND. So we are having an OR symbol like this, XOR symbol is like this, inverter symbol like this, shift right and shift left. You know this one very well. Okay, so this all these are supported by the C. So this can be supported by the, so we can able to see this bitwise logical operations, how the C operations are going to be happening. So you know these truth tables also, and R, XR, inverter. So inverter is nothing but it will going to be taking only one input. If it is a 0, it became as a 1. If it is a 1, it became as a 0. Like that. You know this one. And is nothing but if both inputs are 1, then output is 1. R is nothing but any one of the input is 1, output is 1. XR is nothing but for odd number of zeros, it's going to be having a 1. Okay. For odd number of if both are equal, the output is 0. If both are different, the output is 1. That's the XR. Like that, we're able to see. That's the inverter we are going to be having. Yes, like bitwise operations we can able to. Please look this can be logical operations. So how we can use the logical operations? Okay, this program will tells how we can able to use the logical operations. An example program. This is an example program. That's why I have given an example. See, for example, P naught is going to be having a unlink between these two. One data ANDed with the another data. That data is going to be stored into the P naught. P naught port P0.
Sorry, sir, the
Next.
slides are not changing, sir.
Now
No, sir.
I will try. One more. So I think you are looking into the bitwise logical operations. Is
Yes,
that
sir.
slide is visible? Yeah. Now check now. I
Yes,
have
sir, it's
changed my.
changing, sir.
Yeah.
Yes, sir.
Okay. Yeah. So this is an example how we can able to use the logical operations. Something like this. So just taking a data and doing some logical operations. So you can able to observe the symbols and or XOR inverting, shift right with the 3, shift right with the 4 units, shift left for the 4 units, like that. Okay, so this is a simple. So in order to make you familiar with the syntax, we have written a simple program like this. Okay, so after this is so write an 8051C program to toggle all bits of the P0, P2 continuously with a 250 millisecond delay. Use the inverting and XOR operators. Use the inverting and XOR operators. So I don't want to give the data directly. So like 0x55 or 0xAA. So I need to utilize inverting operation that's called as a tilt. Inverting and XR cap. How we can able to do that one? So we know how to read the data from the P0 and how to read the data from the P2 and how to produce a delay. Just what we required is how we can able to give the data 0x55 and 0xAA. Instead of giving the data, can we do any logical operations such that we can able to take a data and do a logical operation and we can able to do the toggling. Okay, look here. So we have given something like this. So first, we have taken the P0 and P2 directly as the 0x55, 0x55. Both the data is the 0x55. Look at this carefully. And so P0, I am inverting that one. Inverting of the P0. You can able to do that 0x55. If I invert that one, it became as a 0xAA. Okay. Next, you can able to see here. P2 is equal to P2 of 0xFF. So XRing between the 55 and FF. It will also invert that one 0xAA. Okay. How we can able to use the inverting operation and how we can able to use the XOR operation. So first we will give the data directly, then we are going to be utilizing the logical operation and we are going to be producing the delay. Then it will go like this. P0. Previously it is going to be having a AA, then inverting is nothing but became as a 55. P2. Previously P2 is a AA, so XOR operation with the FF, it became as A55. Next, it will give a delay. Again, it will go to the while loop like that. So like this, it continuously execute by giving the toggling of the bits and giving a delay of the 250 milliseconds. So this is a very simple program. So what you need to understand from this program is how we can able to do the logical operations like inverting and XOR operations. We can able to do the AND, OR, all those things. How we can able to do that one? We need to understand that one. Okay. Next. Yes. See here. I will give one more example. Read a data or get a bit from P1.0 and send it to the P2.7 after inverting it. Take a data from P1.0. If it is a 1, invert that 1 as a 0 and send it to the P2.7. Simple thing. You know how to read the data and you know how to invert. Just by putting a tilt, the data will be inverted. But here I am not going for the entire byte data. I need a bit data. That's why you need to utilize the S bit. S bit is a keyword which is going to be telling of the bit data. And we need to tell from which port I am going to be taking the data as a P1 cap of 0. Don't confuse there. There also we are going to be utilizing the cap. The meaning of the cap there is P1.0, not exclusive R. This will be representing the port 1.0. Here the cap meaning is in the S bit, in bit is equal to P1 cap of 0 is nothing but I need to take a single bit into a variable in bit from P1.0, port 1.0. That's the meaning of this entire statement. Okay, second one is going to P2.7. Next, this is the bit data. So S bit is going to be utilized for the ports, whereas for the variable, I will use the keyword as a bit, M bit. This is the variable M bit, which is capable of holding only one bit. Next, M is equal to in bit from P1.0. I will take the data into the M bit and I'm going to sending out to the P2.0 with the inverting bit. Just I will put the tilt in front of M bit, then it became as a inverting of that. So here if the in bit is 0, then it output became as a 1. If it is the in bit is equal to 1, the output became as a 0. Like that. So read the data, invert it, and send to the data to another port. So this is the simple program. Example program. How we can able to do these things. So if you can be able to understand these programs Okay. Hello. Audible? Hello.
Hello, sir. Hello, sir.
Hello. Yes.
Sir, my voice is audible, sir. Hello.
Yeah, Suresh, your voice is audible.
Okay. Your voice is audible, sir.
Okay, then. So just now I lost my connection. So yes. So we are here. I think is it visible? Slides are visible to
Yeah,
you?
visual, sir. Yeah,
Please
visual, sir.
respond. Yeah. So we will go for the next program. Okay. So this is another program. So where read the data from P1.1 and P1.0. Sorry, P1.0 and P1.1. Okay. Read the data from P1.0, 1.1. So these are the two bits. Okay. And issue an ASCII character to P0 that if P1.1 and P1.0 is 00, send 0, like that. P1.1 is 0 and P1.0 is equal to 1, send 1. 10, send 2. 0001 10 10. Up to that we have taken 1 we can able to extend this one to 1 also. Send 0, send 1, send 2, send 3, like that. Okay. So this is an example program how we can able to read the data P1.1, 1.0 and 1.1 and comparing that one. If these are going to be having a 0, 0, 0, 1, 1, 0, 1, 1, send an ASCII character. Okay, like that. Now, so what we can able to do is P1 as a input port, read P1 because we need to read the P1.0 and 1.1. Make all bits except D0 and D1 of P1 put the masked value into X. Okay, for example, let us take if X is equal to 0, send 0 to P0, else if X is equal to 1, send 1 to P0, else if X is equal to send 2. Use the repeated for the step 2. So these are the steps we are going to be having. Okay, so first let us take, I am having a P1.1, so port P1. So in this one, I am having a 8 bits. Okay, so first we will take all the bits. Okay, next we will mask it. Mask all the bits except D0 and D1. How we can able to mask? To mask any bits, so just simply you do the XOR operation. Okay, or AND operation, such that whatever bits we require, that bits you need to make as a 1 and remaining bits you need to make as a 0. Okay, if you make like that, you can able to have a number, that number is 03H. So that's why see here in the program Z is equal to P1, so we will take an unsigned character Z. So we are reading the data into the Z. Next, we are masking the unused bits. So that's why the data became as a 0x3. Okay, next. So after this one, we will try to put the case 0. If the case 0, P0 is equal to 0. Okay. In the case 1, P naught is equal to 1, case 2, P naught is equal to 2, like that. We can able to send. Okay, so we are trying to reading the value with the Z. Okay, depending upon the Z value, if the Z is going to be having something like this. Okay, so let us take, I will try to manually, I will try to check this one. Okay, Z is equal to Z of and of 0, 3. Let us take the Z value, the input value is going to be having a 0, 0, 0, 0, 0, 1. Okay, 1, 2, 3, 4, 1, 2, 3, 4. So last bit, last 2 bits are that is what I like to say is LSB is a 1, remaining all are 0. What happens? If I do the AND operation between them, the LSB became as a 1 and remaining all became as a 0. AND operation is nothing but that one. So what's the value of the Z? The Z value became as a 1. See here. In the if condition, I'm going to give it as a Z. The Z value is a 1. Then it will go for the case 1. Then the P naught value became as a 1. It will send a ASCII value 1. Like this. You can able to extend this case to the P naught case 3 also. Then we are going to be sending the P naught with the 3. Like that. Okay. So this is the simple program to read the data and check the data and send the ASCII value according to our requirement. Okay. Okay. So try to understand this statement very carefully. Then you can able to understand the total program easily. Simply reading the data, masking the data, then we are going to be taking the data and writing a case values like this. Send this one. If the case is 0, send this one. Case is 1, send this one. Case 2, send this one. Like that. So these are the ASCII values, not direct value. That's why we are putting the inverted commas like this. Then it became as a string. So there is nothing but ASCII value. Okay. Okay. So this is how we can able to read the data, mask it, check it, and send the data to the port. Okay. So we will try to execute all these programs in 8051 kit. So we are having a 8051 kit, and we will connect 8051 kit with the LEDs, input devices, output devices, all those things, sensors and all those things. We will try to execute this type of programs, and we can able to see on real time how these programs are going to be working and how the outputs are given, how the outputs are. Okay. So this is how we are going to be having up to now. So in the next class, we will try to discuss about the data conversions. So from packed BC to ASCII, ASCII to packed BC, and binary to hexadecimal, binary to decimal, ASCII conversions. So in the next class, we will try to do this one. So after that, after completion of this one, we try to do all these things in the kit. Okay, so we are having a Keel software. On Keel software, we will execute these programs. Okay, then we will dump flash these programs into the 8051 kit, and we will check how the outputs are, all those things. Okay, so we are completing this session today. So if you are having any doubt, please ask me. Okay. So if you don't have any doubts, okay then. So we will meet tomorrow. Good night. Bye bye.